Okay, I think we'll get started. Good morning. I'm Jim Kosmala, Vice President of Engineering at Okuma, and co-presenting with me is Dr. Andy Henderson, Industry Analyst at GE Digital. Okay, it's day 4 of IMTS. Many of you have had a chance to walk around the show a little bit. Quick show of hands, how many people here have seen something at IMTS about the industrial Internet of Things? Okay, that's pretty good. Pretty much in every hall, in every booth, if you're looking for it, you can find something about the industrial Internet of Things. Some of the things are a little more near-term than others. Some of the things really are pretty far out there in the future before they'll be ready for manufacturing floor use. So what we wanted to do today was sort of sift through some of the noise and show you some real applications currently in production, and show you a little glimpse of the future as well. The industrial Internet of Things has grown to mean a lot of different things, but at the highest level, it's still about using data to make better decisions in manufacturing. What I want to talk about is really 3 things, 3 walkaway items that hopefully you remember. Why get connected? You know, Okuma's mantra here at the show is get connected. And we want to share a couple of 2 compelling statistics taken together that really put up a business case for that. 3 reasons why some are not connected yet, and talk about countermeasures for that as well. And some applications in production. You know, some might be wondering why GE and Okuma, why are they presenting together? Well, we've been working together for years collecting data for making better decisions in manufacturing. We want to show you some of that. We also want to show you a little glimpse of the future of a new technology. You'll be seeing a press release coming out soon about something called Predictive-Embedded, where we're running Predix native on the machine tool itself. And so, you know, you might be wondering, Predix, I know a lot of people have heard of it. You may be seeing the commercials on TV during the Olympics and things like that. But I was surprised there are a couple people that I met here at IMTS that said, oh, what's Predix? You know, maybe they've heard about it, but they're not quite sure what it is. It's GE's IIoT, their Industrial Internet of Things solution. You know, about collecting data, using data to make better decisions. Why is GE into IIoT? GE is one of the largest manufacturing companies in the world. They do about $50 billion in manufacturing in very diverse industries with very different parts, different processes, different data. So when it comes to IIoT, GE is their own biggest customer. They do it for themselves, and now others can benefit from that. So we want to show you some of those real savings and also a little glimpse of where we're going in the future. Machine tools have evolved over the last decade from, you know, the electromechanical servo systems into these intelligent technologies where we're now embedding more and more sensors in the machines, accelerometers measuring vibration, thermal sensors, acoustic sensors, really for the machine control to improve operation of the machine, speeds and feeds, cutting conditions, you know, offsets based on sensor feedback. Well, as we move into the brave new world of IIoT, those sensors become a terrific source of raw data for big data analytics. By connecting to a network and uploading that data, you can compare it with other data, not even from the machine, maybe part quality data from the CMM or operational data, and, you know, cluster analysis, anomalies, cross correlations of data can be discovered. You know, that's IIoT and big data analytics and using data to make better decisions in manufacturing. So I mentioned, why get connected? 2 compelling statistics. Average spindle utilization in the US is about 65%. That means, by definition of average, half are below that. And when you consider that, and the other statistic being only about 10% of the machine tools in the US are connected, it makes you wonder, you know, how do you know where your spindle utilization is? You know, I don't see a lot of the old industrial engineers with a stopwatch and clipboard anymore. You know, getting connected is really easy. You know, so we have an opportunity here. Stop for a second. forget you're here. Go back home in your mind. The last computer you bought, your home PC. You know, you bought it maybe at Best Buy or at Walmart or online. You got your computer. You plugged in the power cable. What's the very next thing you did? You plugged it into the internet, or you connected to your Wi-Fi. You know the values there. it's easy to do. Connecting your machine tool is just as easy. Many of you may know Okuma Control, it's PC-based open architecture. It's been for 10 years. And by PC-based, I mean it's literally an Intel i7 dual-core processor running Windows identical to the laptop we're running this presentation on. So if you can connect your PC, you can connect your machine tool. It's got the same Windows network control panel, the same network center, same little icon down on the system tray. So if you can connect easy and knowing, looking back at the 65% spindle utilization. If you can connect easy, a simple red, yellow, green machine status, machine stopped, machine's idle, or machine's running. Simple red, yellow, green could get you approaching, this is 5 hours, 5.2 hours in an 8-hour shift. Simple red, yellow, green will get you approaching 7 hours pretty quick. So if you can connect it easy, and you could get some simple red, yellow, green, why wouldn't you do that? And we'll get back to that in a second. When we first talk about a little bit about that red, yellow, green. This would be an example of, say, a very simple entry-level asset utilization example. You got the layout of the machines in a factory, red, yellow, green status of each. It is instant and actionable. You can tell immediately if a machine went down and why. You can see if things are blocked or starved upstream or downstream. This happens to be an actual screenshot of a 70-inch touch screen in the front of the Okuma booth, and these are the machines in the Okuma booth. They're all live. It's all real red, yellow, green status of the machines, just showing you a simple, very, very simple entry-level IIoT. If this were a real production facility, obviously you wouldn't have machine specifications over here, brochure stuff. You'd have, say, your production schedule, maybe a countdown timer of how many more jobs he has to build in this current batch. And oh, by the way, you could tell them this is the next part you're making, and you're going to need this work holding and this tooling and this NC program. Help them with the setup. That's the big source of the yellow idle time, is people are usually wondering what they're going to make next, and they don't have the right stuff to do the changeover. So it's very simple. Feel free to go down and touch it. That's what this little hand here is for. True story. We have this in our lobby at our headquarters down in Charlotte, and it sat there in the lobby and it looked real good. A lot of people would look at it but really wouldn't mess with it. So we put a big sign on the top, a physical sign that said, "Touch me." And it worked pretty well, but our receptionist really wasn't fond of the sign. She liked the touch board, but she wasn't too fond of the sign, so we put this little hand here. Point is, go touch it. All the value's there, and you'll see how easy it is to kind of sweep through different pieces of information. All that come from MT Connect just by connecting your machines. So it's red, yellow, green, very simple asset utilization, and of course, there's a lot more to IIoT than red, yellow, green. There's machine health, predictive preventative maintenance, energy management, consumable management, quality. It goes on and on. The point is, regardless of the category you put the IIoT improvement in, the steps are the same. Get connected, get insights, get optimized. This predictive maintenance, machine health, and the previous red, yellow, green process optimization, both are simple examples that Andy is going to show you real-world savings achieved in production today in both of those areas. We can't talk about all the areas of IIoT. That could be a conference all by itself. We just wanted to show some really simple, low-hanging fruit in benefits of getting connected. So now I want to talk a little bit about how simple it can be to get connected. You saw earlier, physically as easy as connecting your PC at home. On the software side, this is the Okuma App Store. myokuma.com. We've had this out for 2 years now. Most of the apps on the Okuma App Store are free. Like other app stores, Okuma wrote some of these apps, but more were written by others, by customers, distributors, partners, like Sandvik. Sandvik has apps up here. Renshaw has apps. You can see ABB, Delcam, Bloom. This app up here, MT Connect, Agent Adapter, it's been on the App Store for exactly 2 years. IMTS 2014, we put that up there. And it is the second most downloaded app on the App Store. Well, some of the people that download, we got some feedback, some that downloaded it, would download it and run it, and then they'd say, "What is it doing?" You know, streaming MT Connect, it's XML data, it's invisible. They couldn't see it. So we put these two apps up there, MT Connect Display and MT Connect Display Mobile. They are both free, open source apps. We didn't write them. You can get the source code, same place we did. They are agnostic. They'll display any machine tool, MT Connect, from any other brand of machine, from any device at all, robots, CMM, gauge, anything. They're actually a terrific little MT Connect commercial. If all you input to it is an IP address, and if that IP address is streaming MT Connect data, it displays it. It displays exactly what it's streaming. So handy little tool, makes it easy to get connected and get started. Oh, one last quick note on this MT Connect adapter, because it is getting so popular. Okuma is going to start shipping them on our machines. Everything that ships from the factory globally will have the MT Connect already installed on the machine, on board. We'll still leave this app up there on the App Store, of course, because, I don't know, someone might get a new machine, try it, start using MT Connect, and say, oh, now how am I going to connect my others? You know, you'll still be able to download that and connect and run to it as well. So, in today's world, where everything's on the go, we're mobile, we do everything on our cell phones and tablets, and we've been mobile on the app side. And back up real quick 1 second. We've got a couple apps like this, Machine Alert and OSP Alarms. Those have both been on the App Store for 2 years as well. Real popular. What they do is you can set up triggers in your control, and it'll send you an email when that happens. So you might even want to run a test or something like that, and then you go to a different part of your plant, or you're out to lunch, or you go to Chicago to a conference or something. When those triggers occur, it'll send you an email. In fact, this one will attach a screenshot of OSP right at the time those triggers happen. So you'll get the email and you'll get a screenshot so you can see exactly what was on the control screen. Point is that, you know, Going Mobile's been out there a while on the machine control side. It's available now for IIoT as well. So this is that free MT Connect Display Mobile. That's on my cell phone. It's showing you the machines connected in the booth. Again, live actionable data, simple red, yellow, green. Now, that's all you get with that free app. Some might want to go and get a little bit more data, a little bit more detail, start trending it and see how the trends go over time. You can still be mobile, but you might want to go to, say, a tablet and more of a full service package like a GE Predix shown here. This is also a real actual screenshot. These machines are in production. They're not at GE, not at the trade show, but at a real customer in the Northeast U.S. And you can see a little bit more detail can be provided. You can do a little more analysis than just a simple red, yellow, green, and still be mobile. Okay, so key point is that all of these, the last few slides are just intended to give you a flavor for some of the benefits, low-hanging fruit in getting connected and getting started. So, why are only 10% of machines connected? A Smart Industry survey says all the reasons fall into really these three buckets. Number 1, education; 2, financial; 3, security. In that order, by the way. And I'll attest, I can't tell you how many customers have come to me and said, hey, I got some of the best machinists in the world, but they don't know IT. You know, IT is a foreign language to them. And oh, by the way, there's an IT in IIoT. And so how do we get them through a learning curve and get connected? And that's the key to that one. How do we do it? And then right after they get past the how, they're saying, why would I do it? What's my return on investment? What's it going to give me? That's the financial. And then once they get past that, okay, I know how, I know why I'm going to do it, and I'm going to do it. What about security? Well, Okuma's focus in this whole mantra of get connected is first and foremost to make it extremely easy. Easy physically as connecting your PC at home, as easy as you do every day with your smartphones or tablets. Download the MT Connect app, download a free, and that gets into number 2. Making it extremely low cost. We've got a display out there now that's free, so getting started has a very low entry cost. And third, on security, our focus is on being scalable. We know IIoT is not one size fits all. And so we really focus and really encourage people to start small and be scalable and grow up. You know, scope creep, we're all familiar with that on projects, but a lot of times it's forgotten. Scope creep exists in IIoT as well. And so we encourage a starting small, walk before you run kind of approach. And being scalable, starting small, is really a great countermeasure for all three of these. Starting small is easier, so it helps with the education curve. Starting small is lower cost, or in some cases free. And starting small can greatly minimize or even eliminate the security concerns. So before I talk, I will get back to security in a second. Let me just talk a little bit more about being scalable. You start with your machine on the floor. It's got software on it. You connect the machines to a network. You don't have to jump into some full-blown IIoT comprehensive system all at once. That would be a scope creep kind of challenge. You can start small with just a simple red, yellow, green analysis. Get comfortable with that. When you're ready to move on, you can move into, say, a machine health, predictive, or preventive maintenance sort of scenario. And there's a lot of packages out there like that. There's Okuma is partnered with several of them. Freedom eLog, Predator, Memex, GE Predix. There's options and that'll help you with machine optimization or machine health and process optimization. And then when you're ready, you can grow up into a large-scale type of implementation of, say, a brilliant factory in GE Predix. That's an advantage in something like a Predix, as you'll see in Andy's presentation. They start small and move up into a medium and large-scale implementation of IIoT and stay on the same vehicle of Predix the whole way through. So, a couple of comments about security and being scalable. And first and foremost, I need to preface this with, I am not an IT security expert by any stretch. Just want to share some observations. And clearly, security is extremely important. You can write that down. I said that. Security is extremely important. But it's also important to not blow it out of proportion into a Y2K doomsday kind of scenario. The analogy I use is driving a car on the road. You know, they say statistically driving to and from work is one of the highest traffic accident statistics. But we still do it. We know the value's there, and we just take precautions and measures to compensate. Seems true for IIoT security. And no doubt, big companies, top Fortune companies could be targets by foreign states that aren't happy with something someone did or didn't do, or capitalism, or who knows what. But for smaller companies, your machine tool, it's not Bank of America. There isn't a whole lot there that's desirable for a hacker talented enough to get to it. So for smaller companies that aren't targets by foreign states, the concerns are really more along the lines of general viruses or malware, all of which can be easily prevented with just good, safe practices. Again, it's like driving. You know, safe driving is more important than a seatbelt. Okuma has observed that security is mainly achieved by employees being conscientious about security and exercising company-wide security measures. So with that preface, a couple of comments about, or observations. MT Connect, it's read-only. There's inherent security there. It's streaming XML data out. It's a check valve. There's nothing coming back in. So there's some inherent security. Number two, you don't have to plug right into the internet, the World Wide Web, immediately. You can connect on a subnetwork. An example of that is down in the Okuma booth. There's exactly 18 devices on that wired network. 17 of them are machine tools, and the 18th is that big 70-inch touchscreen up front. That's it. There's no way for a hacker to get into that. And third, if you're still concerned about security, look into, go with a comprehensive top security way to go, like a Predix, where you've got data encryption and firewalls built in and inherent security. So clearly security is a big topic. It could be a conference, so it is a conference of its own. It's a big topic. My only point was to just point out a couple of simple countermeasures, like MT Connect being read-only. Not everyone's aware of that or the inherent security that provides. Okay, so what's new with GE and Okuma. What are they collaborating on? You start off here on the right side looking at Predix Ready. You Google Predix Ready, you'll get a page full of hits. This has been around for a while. This is the way everyone would connect to Predix today. This is the way it's done. The key here is this Predix Field Agent box, okay? You'd have multiple machines daisy-chained down here. They'd be feeding your Predix Field Agent with MT Connect or OPC UA, you know, like with Industry 4.0. Either one, they'd all be sending data to this Predix machine field agent, and that field agent would be sending your encrypted Predix up to the cloud. As I mentioned earlier, Okuma's control is a PC. This field agent box is a PC. All we did was took this Predix machine runtime app and we're running it directly native on the machine tool itself for Predix embedded. Seems simple. You think about it, the future. You know, our children's children, all machines will run this way. They'll have data collection utilities native on the device itself, and they'll be sending data to a cloud, and it'll be wireless. You know, that's a clear step. The field agent box, it's not going away anytime soon. Number one, not everyone can run the Predix machine app directly on their machine yet. And for older machines, you know, Okuma's got a lot of Okuma machines older than 12 years old will connect through a field agent box as well. So while that's not going away anytime soon, you know, the partnership of running native direct on the machine has some key advantages. Number one, network traffic goes way down. Over here, you've got MT Connect polling at some polling interval, and you've got mega data from all your machines coming up here to this. So a lot of network traffic of data. Over here, this MT Connect really isn't going external to the thing. It's just using it. We use parts of MT Connect to access Okuma's API layer to get machine data and feed it right to this Predix machine app running right on the control. So it's really not going anywhere in the network. And then you're just sending event-based changes to the Predix cloud. So reduce network traffic. Number two, obviously, there's no box. That can be big from less hardware, less cost, less wiring, less confusion. People want to pull in IT people when they start looking at this, and this is incredibly easy. It's running right now today down in the Okuma booth. You can see the Predix machine running. They're pretty excited about how quick they could implement it because there's no IT infrastructure involved. A good analogy a friend once shared with me was that I mentioned earlier, back on your home PC, you know, you get it, you plug your power cable in on your home computer, you plug it into the internet. What's the next thing you do? You click Internet Explorer because it's right there on your machine. You know it, you trust it, obviously it's worked out, the builder put it on there. People that want to get started with IIoT, collection of data, it comes on the device, all they do is connect it, and they hit this button and they're sending data to a Predix cloud. That's an important step in the evolution of a technology, progress. And people need, we need to make it simple. Our children expect it that way. They expect it to be very simple and intuitive. And it comes loaded, it's already been tested, it already works together. So it's a seamless solution. So in closing, that's really our whole pitch is about get connected. Make it very simple, very intuitive, progress the technology, and get everyone online. Get connected to improve your asset utilization and productivity. Sorry. I don't know if that's as loud as it is for everyone else. Getting connected with CNC machine tools and using data to make better decisions in manufacturing can be as easy as connecting your PC, and you can do it today and get started for free with MT Connect display apps. And so before I turn it over, let me ask a question you might be wondering. So if these MT Connect display apps are free, why would I need something else, like say a GE Predix or something? Well, we find data is like Lay's potato chips. No one can eat just one. Once you have one, you're going to see the value, you're going to want more. Just like plugging in your home PC has become second nature, you know the values there, plugging in your machine tool will eventually be second nature as well, and you're going to plug that in. Deming once said, without data, you're just another person with an opinion. Connecting your machine using a free MT-Connect display app shows you what you've been missing. It shows you what data can do for you. That's your first potato chip. Once you get that, you're going to want more data and get more out of it. Another analogy I use is you can go to Walmart and buy just about everything you need in life to live. But some things are worth stepping up a bit to, say, a Target or even a Macy's. By plugging your data into a cloud, you're plugging into a full-service data internet connection that can look at your data every which way you ever wanted to, and in some ways you haven't thought of. So with that, I'd like to introduce Dr. Andy Henderson. Andy is industry analyst at GE Digital, but that's actually a recent position for Andy. He just transferred into that position earlier this year in 2016. For the past 5 years prior to that, Andy was a manufacturing engineer at GE Greenville's gas turbine plant. Some of you may recognize Andy as one of the recipients of the SME 2016 Outstanding Manufacturing Engineers Award. My point is, these applications he's going to show you, Andy did these as a manufacturing engineer. So while they might not be the Star Wars futuristic IIoT things you might see here some places at the show, these are very real. The applications are in production, they are running, and the dollar savings are also very real. With that, thank you very much. Andy?
Thank you very much, Jim. Yeah, please. Jim. That was a very kind introduction, but I do want to say that the applications that I'm going to show, it wasn't just me. There's a team of people working on this, and I think that will become evident. And so I'm going to talk about how GE is applying IIoT to manufacturing, and I'm going to start out by saying why is it important to GE in the first place, and then how do we wrap our heads around it, and then dive into some real examples from our Greenville plant, and then some things about what we're thinking now, and then we'll open it up for questions. So manufacturing at GE, as Jim mentioned during his discussion, GE is comprised of a lot of different industrials. And inside of those industrials, we spend on the order of $50 billion per year in manufacturing across 400 plus plants. I saw these numbers get updated frequently, and I saw some numbers saying that we actually have closer to 500. But the point being that very small percentage increase in efficiency, maybe 1%, could lead to some very large savings in manufacturing costs for us. And so we care a great deal about looking for new technology that can help us realize these types of gains in our own operations. So how do we wrap our heads around industrial Internet of Things? So GE makes wind turbines, so we tend to think that the world revolves around a wind turbine or a gas turbine or an aircraft engine or whatever, the other things that GE makes. Keyword being things. These are the things. Me, I'm a manufacturing guy, so I tend to look at it and say, well, gee, I have a thing inside my factory, a machine tool, possibly, likely an Okuma machine tool. And so I want to get those things connected, and what GE set about doing was creating this platform by which all these things can become connected so that we can start doing some analysis and getting insights and getting optimized, just as Jim said during his discussion. And I don't want to labor on all of these things in here. This is an example of an architecture, and there are variants of this architecture, but the point being is that GE has put considerable thought into what this should look like, and also into how these applications should be built, who should we be working with, what should we be doing, all for the purpose of getting back around to that factory and that machine. I guess one thing I neglected to mention was that in most cases it's not just one machine, right? There's multiple machines, there's a robot, there's a CMM, there are all your different enterprise data systems that you have inside your factory or inside your manufacturing enterprise that you want to connect to. So internally we talk a lot about a brilliant factory, and what this picture is showing is where does that brilliant factory sit in this digital landscape. GE has been going through a digital transformation, and so where that's one area that could start is inside of your manufacturing operations. And so we started thinking about our manufacturing operations and started thinking about this brilliant factory concept. Well, so what you see here is a whole lot of other stuff around it, and this sort of represents what we call the digital thread. So data might come in from your sales team, your marketing team about customer requirements. Then you start putting those requirements into design. From design, the models get handed off to manufacturing. Manufacturing takes those models and starts coming up with cutting tool paths, other production information, and some of that gets fed into your factory, some of it goes into your supply chain. There's all sorts of feedback loops from the factory back to, say, back to the virtual side of manufacturing, back around through your customers and your repair centers, back into your sales and marketing groups again to drive further requirements. So there's this loop that the thread runs through, and there's all these different segments that the thread touches. And so all of this, what GE sees is that all of this is for the purpose of decreasing cycle time, increasing productivity, increasing margins, increasing quality, and in the end, happier customers. And going back to my first slide, we're doing this at a fairly large scale across our own enterprise, and we think that we're doing things that are important enough that we should share with others out in the manufacturing or in all industries and manufacturing specifically. So as Jim mentioned, I come out of Greenville. I still sit in Greenville, even though I've changed positions. But my first 5 years with GE, I was a advanced manufacturing engineer in the plant, or in GE Power. A lot of that time was in the plant. But what is Greenville? Greenville makes gas turbines. It's a 1.5 million square foot manufacturing facility. Something on the order of 430 different devices that we want to connect and start gathering data from. 300 of those are CNC machining centers. So in addition, we do welding, assembly, spray coating. There's new make gas turbines as well as repair. And we also do a number of different components. And this is just some information about our turbine products. And just for scale purposes, a person would stand about this tall next to this thing.
It's humbling.
So as that internal team started thinking about Brilliant Factory and what does it mean to us internally, I think we're not unlike just about every other manufacturer, that we think about ourselves as a cost center. And so we sat down and we started thinking, well, where are our major costs inside of our plant? So energy management is a big, energy is a big cost, and we decided we needed to focus on energy management. And really, I think that there's a lot of facilities management involved in this as well, because we're talking about electricity, but we're also talking about process gases, building management, compressed air. Another key part of it was maintenance of all this equipment that exists inside that plant. So we focused on machine health, just some things there that we're working on are like preventative maintenance timers, moving from calendar-based to actual hour-based maintenance schedules, and gathering that actual utilization, those actual hours from our machines on the floor. Then we have a number of different dashboards to help us manage work orders and our maintenance schedules. Then jumping to the other corner over here, consumable management, so things like cutting tools, even PPE is another great example of where we're finding savings in this corner. And then the other one, the one that I was mostly involved in, was this process optimization. So when you look across all of these, what do you do to your process to make it run more efficiently, more productively? And so that's how we in Greenville thought about this concept of the Brilliant Factory. And so what I'm going to do now is, I have 3 examples here from energy management, machine health, and process optimization, and they're really in that get connected phase and get insights. We're still proving out different use cases for get optimized, but this is really in that get connected and get insights phase. And so what we see here is we have a 1,000 horsepower motor connected to one of our main air compressors. This supports a large part of our plant. So if this goes down, then a large number of our processes stop running. Utilizing sensors and some software from one of our businesses, we put an accelerometer at that motor for this main air compressor. And based off of knowledge about rotating components from our external businesses, we knew what frequencies we should expect to that accelerometer to pick up when it was connected to this motor. And when we started to see a frequency outside of the normal pop-up on this graph, then we knew that there was something not right about this particular asset. What it led us to do was to go do some investigation, and what we found was that one of the oil rings on a bearing wasn't working properly, and so this bearing wasn't getting oil, and what you see is that is the wear that has occurred there. But the point of this is, we used the data, we saw that something wasn't right, and we scheduled some downtime before anything catastrophic happened, so before the processes stopped. And this ultimately, it eliminated the need for expensive new components, but it also prevented that excessive downtime in our production. So saved on the order of a few $100,000 in overhaul costs, but that's not even including the cost that was avoided because something catastrophic didn't happen. And this down at the bottom was kind of our mantra, right? We were going to take data, turn it into information, translate that into action, and we're going to have money we're going to save money in the end. From an energy management standpoint, again, there's a lot of facets to energy management. One of those is we put flow meters on a number of our different gases inside of our plant in sort of strategic locations in the piping. And what we can see is there was a New York Times article recently that you may have read, where the plant manager in Greenville was quoted as talking about during a snowstorm event and the plant shut down. There was nothing happening in Greenville because we're in the South. There was nothing happening, and what we saw was that we still had a high load or a high volume of gases flowing through our pipes. And we said, well, wait a minute, nothing was happening. Why do we still have those gases flowing through the pipes? Well, it was due to leaks. And because we know where those sensors are located in our network of piping, we can go and we can say, well, this section of our plant is where those leaks were occurring, and we can do what we call a treasure hunt. We can go walk around and listen and try to find those leaks. This is an example of one of those, just like our plant manager was quoted as talking about, but this was on our argon system. And what you see is this was what the load was on the system before the leak was found, and then this was what the load dropped to after the leak was found. And this particular example, just this one example, we've avoided tens of thousands of dollars per year in cost of that gas. When you start to have multiples of these like we have, then that savings really adds up across your entire plant. The other one is process optimization. So as Jim was talking about, some simple red-green information about whether the machine is running or not running. But the key part is we had historical data. That's key here, that we could go back and we could look at long-term trends. So there was a particular machine that was not producing up to the standard that the machine, just like it was, producing the same parts. And the data showed that there was excessive variability. So what do I mean by that? So in your process, you expect it to run for some amount of time, then not run for some amount of time. Maybe it runs for 2 hours, maybe it doesn't run for 15 minutes, maybe it runs for 2 hours, maybe it stops for 15 minutes while they're doing changeover and a few other things. And what they were seeing was that this particular machine would run for less than 2 hours, something else, and then it would be down for 15, 20 minutes, maybe 30, then it would run for some other amount of time, not 2 hours. And so that data highlighted to them that this particular machine didn't have a stable process. It wasn't running the way they expected it to. And that in itself didn't solve the problem, right? But what it did is it gave the manufacturing engineer an indication of where to go look. And he was able to go out with the data and say, I noticed that at 7:15 this morning, or 8:15, whatever, that your machine stopped for 15 minutes. Can you help me understand why? And that drives a much better conversation between he and the operator, because the other scenario is he just walks around at some point during the day and says, how are things going? And the event could have gone by and the operator would have said, well, things are okay now, and that would have been the end of the conversation. But now the manufacturing engineer can use that data and drive that conversation. And what they ended up finding was that the machine wasn't completing full cycles. There were defects and recuts, and then there was excessive idle time between the parts. What it led to was improving the cutting tool utilization, because we found that some of the cutting tools were chipping and not making it through the full life, and there were some parameter issues in that, so that was corrected. The defects and recuts were attributed to the fixture itself and part loading, so that was analyzed again, and that was addressed. And then found that some of the operators weren't following the standard work schedule, so that was a discussion, some training between the operations leadership and the operator to say, this is what the expectation is. All of that led to about a 15% increase in utilization for this particular machine, and again, tens of thousands of dollars in cost savings. This is one machine, and as I mentioned a moment ago, we have 300 CNCs, we have 400 and some odd devices that we're connecting, so this can really add up across that population as well. So what are we thinking about as we talked about get connected, get insights, get optimized? What are we thinking about with get optimized? Well, what if that machine is putting out a lot of data? Okuma's great, they provide us with tons of data. How do we use that to be smarter about our process? Well, we can't, it's not always possible to have somebody just monitoring that data, looking at it, looking for things that to point them towards something they need to go address. What if you could apply machine learning techniques from, say, what's going on, from the things that like Google and other software companies are doing? So you can start to look at, say, spindle load and do some clustering and say, what's normal? So green might be normal, and anytime the curve falls outside of normal, then maybe you send an alert to somebody and say, hey, something's different. And then, well, what do you do if something's different? Then you might start looking at your quality data to say, did that actually turn into an issue? And where was that issue at? Can I drive it back to a specific part of my process? And can I address, say, the cutting tools or the fixture or anything about the process for that particular area? And then, so moving beyond just say spindle load, the Okuma machines also come with a number of different sensors, thermal sensors, vibration sensors, that they're using for their own purposes. We could go put those on ourselves, but why not just ask for it from Okuma. And so that's what we've been in discussions about recently is can we get that data so that we can start to do some similar analysis and get even smarter about how our process is running. So with that, I thank you all. I started out with why GE cares, how we're wrapping our head around it, and then a few examples and thoughts about and what we're thinking about. So with that, I want to turn it over and ask if you have any questions. Yes.
Could you please return to the last slide?
Sure thing. Yes.
As you collect data over time, is there any thoughts to using that data to autonomously self-correct or create alarming that says we've learned over history this die has to be changed, when this happens, so it becomes autonomous in nature?
So
really IIoT.
So the answer is we're thinking about it. Yes, yes. That's a futuristic view that we share with everybody, right?
Is Okuma doing that with their machines and their service to actually call on preventive maintenance in advance of the companies that have their machines? So is Okuma capturing this data from their clients and using it internally too, or is it mostly towards the being utilized as the end user?
What he said. We are looking at it. Yeah, we are starting to collect the data as well. We've made some strides in some areas. We haven't released it out there yet. Up until now, the focus has been on providing that data to help customers, manufacturers, improve their process.
Yes.
You mentioned earlier that the main impediment is education. What do you expect from the educational sector to help provide the workforce that you need?
And I think that's been an ongoing discussion in a lot of circles about, bringing people into manufacturing in general. But I think from an IoT perspective, it's bringing people with even more balance of both the manufacturing side and the IT world and starting to bring them together. I think probably one of the biggest steps is going to come, maybe not even just directly from the education market, but in the manufacturing world, getting IT and manufacturing working together. We kind of joke about we should have the IT department report to the manufacturing plant manager. It helps things a lot.
You should report the findings, but do you have any certifications in mind that would be particularly helpful? Thinking like Network Plus or those kind of certifications.
Combinations of networking with the manufacturing classes.
And I think education also relates to just getting the word out. So things like this, right? What do we do first? Because you don't want to boil the ocean immediately. GE has this internal philosophy of FastWorks, which is basically think big, start small, scale rapidly. So think about the possibilities, pick some small areas to get started and go. And I think that's what a lot of people struggle with. So giving us trying to say, well, here's how we thought about it and here's how we started. I think that's part of the education piece as well, and getting that in front of business leaders to have them thinking about, well, what does that look like in my own business? I think that's part of what the education is saying as well. Yes.
So I'm starting from scratch. I want to get here a decent path. It sounds kind of like set up some network, connect your CNCs or whatever equipment. Start with just monitoring machine status. Okay, that's great. Now I want to know this. Figure out what data you want to collect. Start collecting that and manage it. That's more or less the intended trajectory where we're going, right?
Yeah, that's a fair path, and I think we could have a huge conversation about this topic alone, right? That there's so many different variants that we could take, and even within GE, we've taken a few different variants, right? And I also like to point out we have our solution architect way back in the corner who's staring at his phone. But he loves to talk about things just like that.
So if you're a machine manufacturer, a tool builder, how do you think about capturing some of the value? You know, obviously there's going to be some significant investment to add some capability into your machine. I can see it's clear how the end customer gets value, but how does the machine tool manufacturer justify the investment and capture some of that value?
Well, first off, I don't know that the investment is that large, at least for us. When you're PC-based control already, a lot of the stuff, other things and people and systems do is on a PC, and so we'll readily either integrate with it or can run it right on our platform. So we've been ready for this for a while. But clearly one of the ways we do is, in what this gentleman was asking about earlier, starting to collect more data to find out about common occurrences of, say, hey, all of our machines with, our lathes with, look at all the lathes with 10-inch chucks, say, for example, and when do we see spindle failures, and start to look at a cluster analysis and trying to find, identification of an anomaly, and all of a sudden say, hey, for whatever reason, this lathe with 10-inch in the 1 meter bed fails, 70% sooner than the ones in the shorter half-meter bed. Why, and then start to find root causes to some of those anomalies. And that's the thing about IIoT, it's discovering things, right? A lot of Google's revenue streams come from things they didn't know when they collected the data. and so that's where Okuma will go, and then be able to start to see those anomalies and offer maintenance services. And you hear about that with the GE Aviation. Will call a small airline in Bangladesh and say, hey, your 737 right engine, you need to do some maintenance. You're going to have a failure on that soon. And they go and open it up. How do they know that? Putting sensors in our machines and analyzing it, we can see stuff happening and be able to offer maintenance services to customers to say, hey, it's time to go do change your spindle. Something that offers them a preventative maintenance service.
Systems with, in the first examples, monitoring the flow in your plant air and spindle vibration on the compressor. How was that information gathered? Was it pulled into the GE software, or was it just standalone software from those setups? Or?
So specifically in Greenville got started, and a lot of this has been pieces of GE software that we've used that is being migrated over time into the Predix architecture. So the great thing about Predix is the fact that the internal shops are building things and learning, and then feeding that information into Predix. So you can expect that with it you can garner some of that knowledge that our internal shops have learned. Does that answer your question?
Yeah, that's kind of what I'm getting at. I'm seeing that, you took pieces of equipment that weren't necessarily connected names.
Oh, right.
Equipment, and you got information from them. So were you able to route that information into Predix, or were they just a la carte setups that enabled you? What I'm getting at is, how would I start pulling information off machine tools aren't providing any connected information?
So I think that's another one of those questions that could take a long time to answer as well, and so I think we should talk afterwards about it.
There are, you can put a box on there, and I can show you some pictures of some equipment that we would use to say an Okuma more than 12 years old. We'd use, it's basically, you're connecting discrete I/O, and you'd be, point-to-point interface, collecting data from the machine, and then on that board, turning it into a serial, high-speed serial connection to a box, maybe even a Predix field agent that'll then take it and send it up to your cloud or wherever your fog level server.
So I want to pose a question back to to you guys. I mean, does this help, or is there a better understanding now? I think you had said that you heard about IoT for the first time 2 days ago. Does this help kind of?
Yeah,
2 weeks ago.
I mean, it's starting to come together. I'm kind of getting back to where he's at. It's like, who do I talk to now? I want to hook one of these up to a control panel. And is it the system architect back there that, well, it's okay, here's the Predix box, here's the MT Connect box you need, here's Predix, we'll come in and help you set this up, kind of thing.
So for sure, GE would love to talk to you about all of that.
And that's a little different answer for every person. It's kind of a case by case, depending a lot on the people you have inside as well, and their knowledge level of what they can do. But yeah, we got a solution architect here, so it's a great place to start because kind of bounce some ideas off them.
Fantastic.
All right. Thank you all. Thank you very much.
I think we're done. Thank you.
You're with Okuma.